Thank you for coming. Today we'll talk about search analytics and why it matters, what value it brings to the table. And I'll describe what we've done in for search analytics, what we've built as a search analytics service. A bit about me. I'm an Apache Software Foundation member. I have been associated with Lucene, Solar, and a few other projects from the early days with Lucene since around 2000 or so. I've co-authored the Lucene in Action book, which some of you may have, along with Eric Hatcher and Mike McCandless. In the past, I've started something called Simpy, built something called Simpy, Web 2.0 social bookmarking type of service that was eventually sold. And now I started Sematext, a company that you may have heard of, that focuses on search and some other related areas. I like to come up with ideas, build teams that implement those ideas, and create organizations that are self-sustaining and profitable. So some numbers, Sematext numbers. It's a 4-year-old company with less than 10 people, spread over 7 countries, 3 time zones, and 2 continents, with over, I think, 100 customers. And we are organic in a sense that we are self-sustaining. There's no VC venture capitalists involved by choice, for now at least. For those 100+ customers, we provide mostly services, consulting, development, tech support around technologies that you see down at the bottom. And we also have some products that are tied to either search or data analysis. And you can see the areas that we work on. We help customers with search, with relevance, scaling, performance, all kinds of things. And we use all of those tools for that. Our customers come to us with Lucene. They use Lucene or Solar or Elasticsearch. Obviously, Solar is the most popular of the 3. And this is roughly what we'll talk about today. I'll describe what search analytics is and why I think it matters, why it's important. I'll share some example search analytics reports today. I won't describe all of them because I've already given a talk that goes into more detail and has more examples of reports and analyzes each one of them, what it's good for, and I'll include the link in the talk, you'll see it. And in the end, I'll share some of the information about how we've built our search analytics SaaS. Why we made certain choices and how things work. Before we get started, for real, these are some communication channels that you're welcome to use. Twitter, company, me, hashtags. If you have questions that you don't want to ask during the talk or after the talk, feel free to tweet something using those tags. We'll check them out later and try to answer your questions. I'm not sure why that URL is there, but you could go there and sign up for the service that I'll describe in the end. You're welcome to raise your hand during the talk, interrupt me, and I'll try to answer your questions, and you can, of course, send email. So this is one way to look at search analytics. It's the compass that tells you which way you should be going. The data that you collect, not only search logs really, but also click logs and other search-related logs are your map, and the two work together. There's no point in collecting the data if you don't have the right tool to analyze it, and there's no point in thinking about analyzing something if you're not collecting the data that you need. Another way I like to think about search analytics is as a mirror, something that okay, an example. If in the morning you fix yourself up, get dressed, fix your hair, then you look in the mirror and see if things look good. So this mirror, this search analytics tells you if changes that you're making are actually useful, if you're moving in the right direction, or if you degraded things. This slide is actually related to something that Grant said this morning about knowing what's actually happening with your search. You may think that X is happening, that your users are doing X and having certain experience, and in fact they're doing something different, and they have a different user experience. They actually have different expectations of your search, and that's the yellow or orange circle. And what you think you're giving them is this blue circle. And they do not overlap, and in the area where they overlap is actually the search experience that these people have. And probably because if the overlap is small, they're not going to be terribly happy because their expectations are different. So what may happen is this, where you maybe make some tweaks to the search. You say you want to work on relevance, and you change some, this max, edis max, or whatever parameters, and you think, oh, things have gotten better. I'm looking at my web analytics or looking at some other data, and I think our site became stickier. That's great. People are spending more time engaged with our content, when in fact what's happening is that they just can't find anything. They're refining the query, trying to find whatever they're looking for. So we need something to tell you that. So this guy looks like a guy who has no map, no compass, the guy who's lost, the guy who doesn't have, who's afraid to maybe even make changes, or if he makes them, doesn't know whether they're good or right. So you have to have something to help you out so you're not feeling like this. And if you do not have a search analytics solution of homegrown or something that you bought or whatever, then you may be like this, and you may not even know it, because you may think that your change is actually working well when in fact you don't know. And that is because lots of organizations that we work with are missing this piece of the puzzle. They may work on their UIs, navigation, how they lay out their facets, colors, search box. Search may go through QA, where QAs test out a bunch of queries and things look good to them. They may tune things from performance or relevance perspective. They may monitor the search backend, but they don't actually know what users are experiencing because they don't have a tool. And that's why we've built it. We built something like that. So in 2005, I got a job at a company called Technorati, which some of you may have heard of. Back in the day, it was a big search engine company, and I worked with John over there and Brian, who's going to be giving a talk about Solar Cloud tomorrow. That you should go see especially if you were here for Mark's presentation earlier, that's related. So with John and Brian Pinkerton, who used to work for Lucid, I worked on their search, and from them, when I joined them, I remember thinking, wow, these guys measure all kinds of things, technical and sort of business things. At least that was my impression 6 years ago. I was 6 years younger, less experienced. When I came there, I realized that they measure everything, and that was a revelation to me, and I learned from that. So search is one of those things where you also want to measure everything, not only performance, but also the experience. So that's why you want to analyze the search streams, click streams, and so on. Search analytics will support you design, redesign decisions. Not only will it tell you when you should make some changes, but when those changes are good or bad. It will also tell you whether there's actually a mismatch between what you have and what your users think you have, or the way they are searching your content. They may be using terminology that's different than the terminology that your content has. They may be using the word automobiles when your content has only the word car in it, which is a signal to you that, hey, you should use synonyms or acquire content that these people are not finding. The end goal is to improve the search experience, and for people, when you do that, the green stuff will follow, which is the goal of the search providers typically. So here's my first question, and there are a couple more. What do you use for search analytics today, if anything? So let's start with F. I'm curious who uses nothing. Really? Okay. Either you're shy or you're good. Do you have any homegrown stuff? Okay. Who uses Omniture or Web Trends? And who uses Google Analytics? Aha, interesting. Well, I think there's a slide later. Google Analytics is not really a search analytics tool, but okay, we'll talk about it. So whether you do it yourself or use one of these tools, what happens is there are a couple phases. The first one is obviously collection of data, and typical things that people collect are queries, clicks, and interactions. Sometimes people ask me whether you could just collect, say, Solar logs. The answer is yes, but it's not going to give you everything. And even if you collect clicks, that's not going to give you 100% of the story, because ultimately what you really want to know is what people do after search. When they do a search, click on something, let's say you're an e-commerce company, do they actually end up buying the item they clicked on? Do they end up putting it in a cart? Do they end up engaging with the content, sharing it if it's a news article or something? That's what you want to know. Once this data is collected, it's analyzed, and typical or most basic output are various reports with metrics represented over time. And of course, there's additional data that you can get out of this data that you collect, like you saw in Eric's keynote this morning, where he talked about Search Assist at Yahoo. That's one example. The important thing is that looking at what's going on with your search is an ongoing thing that you should do. Things change, people's vocabulary changes query vocabulary changes over time, content changes over time. People have different ways of searching over time, and therefore those circles may overlap more or less. This is the slide I was referring to. So Google Analytics is not really a search analytics tool. I use it too. So it has very basic search-specific reporting. Or if you can use it for search analytics, then it must require a lot of configuring and customizing, which I haven't done. I'm not an expert in it. But it's a web analytics tool that tells you how people are using your site, where they come from, which queries they've used to come to your site, which pages they've visited, and so on. Not necessarily about search. So search analytics can be more telling because people are telling you what their intent is, what their needs are. Whereas when you're looking at something like Google Analytics or any other kind of web analytics, you are just inferring what they might be looking for when you look at their paths of traversal paths through the site. So ideally, you would collect both web analytics and search analytics and tie to the e-commerce backend if you have some kind of e-commerce service. Here are some of the example reports that the search analytics solution can give you. There are more of them. These are just some, and I'll briefly describe each of them. Rate and volume and latency are really not about behavior, although latency is in a sense that it tells you how quickly people are getting their search results, and that may be a signal of whether they're happy or not. Click-through rate and mean reciprocal rank tell you are hints about your relevance. If people are not clicking through, if your click-through rate is low, people may not be clicking on the results because they're not getting the results that they expect, that they think are relevant. Mean reciprocal rank will tell you that people are clicking very low on the search results, which tells you that your search engine may need some love and tuning to get the things that people think are relevant higher up. Top queries, another thing that Grant mentioned this morning. You need to know, what your users are searching for. So top queries tells you that. There's 0 hits there is a very common report that you see mentioned whenever search analytics is talked about, because this is a situation that most people want to fix. You don't want to give your users a page that says, sorry, you got 0 hits, nothing was found, go away, go home, give up. If this is an e-commerce, if this is a potential customer, that person will likely not come back and you lose some revenue. Query trending shows you query frequency over time. Top seen docs and top click docs tells you which documents people have seen and which ones they've clicked on. And the inverse of that, of course, is what people have not seen and what they have not clicked on. And this MSFT hint for me is a hint to tell you about the unverified rumor that 90% of the content of Microsoft.com has never been seen by anyone. This is unverified, but I find it possible, and I've always wondered what one could do, especially for those of you who have very large indices. If you were to do the inverse of these top seen and clicked documents, what if you were to just remove the stuff that nobody ever sees? For those of you with large indices and performance issues and always desire to improve performance, that could be, a thing to look into. Page and click depth tells you how deep in the results people are clicking and paging, which again speaks about relevance. Facet and sort usage tell you what facet choices people are making or which sort criteria they're using. So this may tell you that the sort criteria that's at the bottom of your pull-down menu for sort is actually the most popular one, and which means you should rethink which sort is the default. If you look here, you'll see another presentation that was just uploaded yesterday that has more details about various reports and their pros and cons. This is my kid. But we'll talk about what we've built to help people with analytics. So what we've built is a SaaS, a search analytics software as a service that you do not have to set up. Well, you do have to set up a little bit, but you don't have to install the complex software. That has numerous reports, some of which I've just gone through, plus some other ones that can show you trends of pretty much everything over time, give you reports with top-end queries, docs, clicks, and so on, and that allows you to slice and dice your data, send in custom filters. There are some predefined and some custom that allow you to filter your data with the dimensions that are specific to your application. So unlike the crowd here, who apparently is set with analytics, our customers need it, and we need it for Search Hadoop and Search Lucene sites because we're interested in improving them and improving relevance, and we need to know how people are using them. So this is, to make things kind of more concrete, this is one view of this thing that we've built. It's a rate and volume report. Up on top, you see tabs with various other reports, and I'll include screenshots of it, of some of them later on, so you can see them. On the right are various filters by time, by query types, origin, by result type, and there are a few other ones that down below that you cannot see that are custom. You can send in these custom filters. Things can be stacked. You see line charts, bar charts. There are metrics that you can choose to include on a graph. Up on top, you see pull down, which allows you to register a bunch of different systems or search applications. So if you have more than one, you can look at this type of stuff for multiple search applications. So the way we went about it is that we developed this as a software as a service, which doesn't mean it cannot run on premises if one wanted it to. But if you run it on premises, of course, that means you need to set up a number of things. Deploying it as SaaS means that you can use it in 15 minutes without doing installations, configurations, and so on. We wanted this to be a multi-tenant solution, which means that we decided not to have separate instances of these for different customers, but they all share one instance that can handle them all. Whether that's a good decision or not, we'll see. Of course, this means that we need to handle lots of data because every time somebody on somebody's site makes a search, a click, pages to results or anything like that, data is sent to us. We need to receive a lot of data at high rates, and we need to persist it safely and process it in a timely manner, and then be able to serve it efficiently and quickly. So that brings us to the cloud, because we don't want to invest in hardware for this sort of thing ahead of time, and cloud allows us for nice and elastic expansion or contraction. So we had some storage choices to make. We looked at the relational databases, of course. We designed the star schema for them, and it's nice to have a relational database for this because lots of people know SQL and they can do ad hoc queries of their against their data. Unfortunately, this thing doesn't scale so well. We could also store data in HDFS directly, but it doesn't give us a nice way to query it. We could store it in Hive, and honestly, I don't recall why we decided not to store data in Hive. It sounds like it would be a good thing to do. We went with HBase, which has properties that we need, and actually Hive and HBase are on friendly terms. They talk, and therefore you could use HQL, Hive query language, to query the data in HBase as well. We considered Cassandra, but back then when we looked at it, it didn't seem like the right choice. Now one would have to reevaluate it, although I've heard stories about, not so great stories about Cassandra, but I know that people also do use it. Our choice was HBase. So question number 2, I guess you kind of answered it. Most people use Google Analytics. Very few people have in-house solutions, so we'll just skip that. Here are a few more screenshots of what we've built before we talk about the backend of things. So you see more about what's happening in the backend and why. So this is a report that shows you how many hits people are getting, and puts those numbers in buckets, so you can see if people are getting a ton of hits or 0 hits, more importantly. And here we see that almost nobody is getting 0 hits. That happens to be, this data is for search Hadoop.com and search-lucene.com. That happens to be because of this one component that we have that eliminates this 0 hits situation. Normally, I think people would get a bigger slice for 0 hits. This is a similar looking report, but with latencies bucketed. Here you want to look for 90th percentile and situations where I don't know if you can see this, but this thing here says 10 seconds to 20 seconds. So you want to look for situations where people are getting, where search is slow. You want to eliminate that. And this thing will tell you if that's the case. This is a report that has, that I can't really show you this in a static screenshot, but it's, you can see, you can select columns, you can sort by different columns. You see queries ordered by count, by click-throughs, 0 hits, MRR, all kinds of things. You can search through this. You can use that search box to limit the queries that you see. You can show different number of queries, top queries, and so on. It's very handy. Up there are some numbers in the totals line that I'll briefly describe right to left. MRR is the thing that tells you how high up on the results people are clicking. You want this number to be 1, ideally. Obviously, it's not so great there. 0 hits percentage, you want that number to be low. Same with 0 hits. CTR, you want to be high. Queries without clicks, you want to be, of course, low. And clicks, you want to be probably high. This shows you about paging, how deep in the results people are paging. You want that to be low. You don't want, here you can see that people are typically staying on the first page of results, which is good. And this is how things work in the backend at the high level. And this is a link to another presentation, a different one from the one before. This one talks more about the backend, about HBase specifically, and about Flume. This talk was given at the Hadoop World in New York in 2010, so it has more of that. So basically, the integration on the left is what you do with Google Analytics. You just put some JavaScript in your search results page, and this JavaScript sends data to us. We capture it, do something with it, persist it in HBase. And this will be more detailed in a bit. The red points there you see are various bits of data that we collect, or one may collect: the query, the suggestions, the autocomplete suggestions that was made, a suggestion that was selected. Did you mean suggestion, whether people clicked on it or not? The hit that people clicked on, whether they paged to next page, and so on. For that, we use some of these technologies, or all of these technologies, plus some other ones, and these are the core ones. The beacons, JavaScript beacons that you put in a page, the receiver, or this metric capture application, which is really just a servlet that listens to your data and persists it. Flume and agents that aggregate this or collect this data, really. Persisted into HBase, and then MapReduce is used to process the data in HBase, aggregate it, and actually persist it back into HBase. And on top of that is, on the other side, what the user sees is just a reporting web application whose screenshots you saw. One page about Flume. It's a log collection service, initially built at Cloudera, now at Apache, going through the incubation. It's scalable, configurable, extensible. You can write different sinks to persist data in different data stores. We helped write the HBase sync for our own purposes and contributed, of course, to open source. It's central manageable, and that's about it. I'll talk about it a little bit later. HBase, you also heard described by Eric this morning. I heard it described as three-dimensional map, which makes sense, but on his slides, if you paid attention, he actually had 5 dimensions: rows, columns, cells, versions, and values of those cells. It's a column-oriented database, meaning that you can manipulate data in a certain column. You don't need to retrieve everything, the whole row, only column or column family that you're interested in. It's built on top of HDFS, which means that the data is replicated in HDFS, and HBase relies on that working well. You can process the data in HBase with MapReduce. So that's also what Eric mentioned. It sort of has a home court advantage that it's nicely integrated with MapReduce. With some of the storage systems that we looked at, like Cassandra, did not have at the time. Now, of course, things have changed. This is the earlier data flow, but in a little bit more detail. So on top is a search service, meaning your application, and those beacons that send the data that comes to us. Those MC apps are really just receivers. They persist data into log files that are then tailed by Flume agents and collected by a Flume collector that has this piece called sync that saves data to HBase. This is really just how data comes in. Of course, there's MapReduce piece at the bottom that processes that continuously. So we chose Flume because of its reliable delivery options, which is not to say that it's always reliable, and the community is working on things like that, including us contributing to that effort. It has a web-based UI where you can manage it easily. It has decent community and decent progress. It joined the Apache incubator. So personally, I'm hoping that it's going to become more stable, because I've also seen people describe it as not very stable. And it has its quirks. Without Flume, we could have done it. We could have collected data ourselves differently, say using log4j appender that persists data to HBase. But then theoretically, it would not have the reliability that Flume provides. We could have also chosen Kafka and Scribe, except when we were making choices, there was no Kafka, and Scribe was in a state that was kind of abandoned by the original creator, Facebook, although I think now I have a feeling that I'm putting more effort into it. We chose HBase because of its scalability, reliability, the ability to store large amounts of raw data that we collect and aggregates, because we can process the data in it with MapReduce easily, because it has fast scans and fast lookups by key. And we can easily expand it by adding more what are called region service to HBase. The community is good and healthy. They're making progress. And as you saw in Eric's talk this morning, companies like Hortonworks and Cloudera are putting effort into HBase and making sure that it's better and better for end users. In the process of building search analytics, we've open sourced a few HBase related things. The top one, I think WD stands for Write Distributor. It's always a common HBase problem that HBase users have, where they use incorrect keys that hotspot writes. The writes end up going to one server when they could be distributed to many. This project helps people solve that problem. We've made some patches to Flume along the way. Challenges that we faced or that are facing are the data size, obviously. There are millions of rows, hundreds of millions of rows in the game. So we, of course, compress things. And nowadays, there are newer, I mentioned LZO here, but there are newer and better compression algorithms now, one called Snappy and a newer one called, I forgot. It's brand new that I heard about the other day. And of course, we prune the data, all data, depending on how long one needs to actually persist it. The challenge is to deal with a very long tail-like distribution of queries, where some queries are mentioned only once or twice or very few times. And the question is, what do you do with them? Do you actually store them, or do you just chop them off? Flume and HBase are getting more mature, but are not super mature yet. Unfortunately, for instance, our HBase collector is such that when HBase goes down, Flume cannot connect to it anymore unless you restart Flume. Another challenge is disk I/O, which on environments like EC2 is not good, which at some point may force us to move out of EC2 and cloud. And now we face the choice also of Hadoop distributions. Which one are going to use? Cloudera's, Hortonworks, raw Apache, or MapR? And can you actually easily switch with them? Are they compatible or not? That's the question we don't actually know the answer to yet. Earlier in the talk, I mentioned this Output++, which is really about the fact that you can get more out of your data, not just create reports, if you analyze it well. The most basic thing is autocomplete, which if you don't have, you should have, and that I heard in Grant Ingersoll's talk in San Francisco earlier this summer in May, where he gave an example of a company that maybe he was working with that was thinking about improving the search and thinking what to do. And in the end, they added up autocomplete to I guess the search form and made that sort of improvement to their bottom line. You could build better spell checkers based on the data that people are entering and self-correcting. You could figure out what the related searches are and offer those to users. You could build recommendations of the data that you collect. You could build alternative ranking models for Lucene based on data you collect. The ultimate goal is to make this overlap bigger. I don't think things will ever overlap 100%, but the bigger the overlap, the happier the users, and the happier the users, the happier you or your boss are. Here's one resource, a book called Search Analytics for Your Site by a guy who I think is one of the couple people that I know of who actually look at search analytics in more detail. And I've known about this person, Lou, for a few years, and earlier this year I realized that he actually sits about 10 meters from where I sit at work, a different company, but he happens to lease a space right next to me. So this is his book. I've read it. It doesn't talk about specific solutions as in ready-made tools that will answer all kinds of questions about user search behavior, but it does describe various things that you could look at and what they mean. The obligatory thing that we're hiring. These are the sorts of things that we work with. And that's it. Thank you.
You mentioned Elasticsearch, so you have experience using both Elasticsearch and Solr. Any insight about real-time search or such?
Sorry, I did not understand that.
Elasticsearch and Solr.
Aha. Well, in this context, are you asking about Elasticsearch and Solr in this context? In general. Okay, so this is my view on it. That's a tricky one.
Apples and oranges. The apples get thrown this way.
Well, I don't know. They're headed in the same direction now. In some ways, Elasticsearch is ahead in terms of what was already done. If you were here for Mark's talk, you see that Solr is kind of playing catch-up, which I don't think is necessarily a bad thing at all, because besides the features themselves in these two solutions, one has to pay attention to the community behind it, the support behind it, and in that case, Solr wins. So I happen to be I'm on both mailing lists, and I see people comparing the two solutions, reaching some incorrect conclusions. People sometimes being really happy that they found Elasticsearch. I don't know, whether Elasticsearch will form the community in the end the way Solr did. I know the author has those aspirations, but it's nowhere near Solr. So I think in the end, you'll have two solutions that are similar, and you'll have a choice. Elasticsearch will eat in a market share of Solr, but I don't think it'll take it away.
You talked about using a star schema in a database and using aggregations and the type. Does that mean that you've ended up constructing a kind of business intelligence type cube in HBase, or have I misunderstood that point?
No, we didn't end up doing that, but the schema and structure of data is such that knowing what kind of reports we need, we can do quick lookups, which is not, I think, the same as a cube or a star schema. Smartly designed keys is one of the ways that we store data and retrieve it quickly. But it means that you need to know what reports you have. If you want to do ad hoc queries, then you need to use something else. Then you may probably not want to use aggregated data. You may want to use your raw data to do your querying.
Otis, how long does it take for new data to be visible inside the reports?
It takes as long as as the MapReduce job that processes it takes, which depends on the volume of data that we receive on one hand, and on the size of the cluster that processes that on the other hand. So if this is MapReduce job, if there are 100 data nodes and data is split and processed in parallel, then it's going to be faster. Currently, I think we have only about 5, data nodes for this particular cluster. So I think in practice for now, it shows up a few minutes after, after the data has been collected, although for search analytics, of course, people don't tend to need this data up to date. The reason it's done like this is because we use the same framework, aggregation framework, for performance monitoring thing that I'll talk about tonight at Lightning Talk briefly. So it's the same sort of data flow, aggregation, and so on, but when it comes to performance monitoring, you need to know about that quickly, right? Something like this, you can look at it, 24 hours later, really.
So does that mean that you fire up a Hadoop job for every click a user does in one of your client applications?
So the question is, do we need to fire a MapReduce job for every action that a person does. No, we collect the data. You saw in one of the slides how the data goes through that receiver, Flume, and ends up in HBase. Over there, once the data is over there, periodically, pretty much all the time, there's something running and processing new data as it comes in. Not for every action, but every n, let's say, minutes.
Otis, I have a question concerning the integration, let's say, with my search application that I'm using. Is it that, did I understand you correct, that you can offer me services on, let's say, on the suggestions or on more like this? Mm-hmm. Let's say I have a Solar server underneath it. Can I plug this into the services, let's say, on a config level, or do I need to work on an application or web level on that?
Or I would say on the web layer or application layer, on the kind of UI layer. So if you use Google Analytics, or maybe any of these other services, when you sign up, they say, oh, here's a piece of JavaScript, stick it in your page. It's the same sort of thing here, stick it in your page, except in case of Google Analytics, for instance, you just stick this in the page and it can figure out everything about what people are clicking on with just you sticking that in. Ours requires a little bit more work in the sense that we can't figure out how long a search took. We don't have that piece of data, or how many matches were made, how many results were returned. So when you integrate things, you put in a bit of JavaScript in your HTML or your results page, and then you have to make sure that this data that you want to collect is actually passed to this, beacon, to basically JavaScript function. So there's a place where you say, okay, this is the how long the query took. So you need to make sure that number is there. If you don't put it there, your report is going to be blank for that, right? All right. I'll be here. If you have questions, talk to me. Thank you.